via screen grab as well. So I will not initiate the recording from the MS Team site. This is being recorded and hopefully I will upload it. If I go by like for 1 hour or 2 hours, so this will be recorded and then I will be. I hope everyone has downloaded these files which are just shared over here at 12:50 p.m. These are some tables regarding SMD. Then there are some data sheets over there, and then the circuit diagram is the very same which we had used already. That is the yellow dot matrix, and I will be. Let me just share my screen with you as well. Okay, meanwhile, since still students are coming in, and I'm going to start in like 2 or 3 minutes from here now on. So if anyone has any issues, before I actually discuss any issues from the assignments which have been submitted to me, so please write down in the conversation window any issues, any particular issues which you actually want me to address, especially from the software point of view, LTM. Please write down in the conversation window. Don't give me a chat message, something over here. This is very important. Please write down in the conversation window, not in the chat window. Actually, I will go on through with the chat windows afterwards, after this lecture, because then I will be separately actually entertaining everyone. So anyone who wants to actually discuss or point out anything, still we have just like 94 students in the class at present. There are like 170 plus students here, so half of the strength is here. So I'm expecting people can be here. Okay, I guess no, I'm not going to discuss roll number. That I will pick over here. Please, Abdullah Sabur, yes, what is about? Please don't give me roll numbers. I will be actually picking up assignments myself from the evaluated ones. The done ones are already done with me, which I have assessed and I have given their marks. So I will be just discussing them. Don't tell me the roll numbers 62, this 73 and 72. I will go with them. Yes, Abdullah Sabur, I guess I went through your email and I also replied to your CR as well that your design was good. And I guess this is okay. So nothing wrong with it. So maybe I forgot to reply you personally, but otherwise I asked your CR actually. Okay, I guess there is as such no issues from there. So one thing, I will just go through my Excel file over here. If you have seen this Excel file, how many layers? Good question. Ji. How many layers can a PCB have? PCB can have like 14 layers, 20 layers even. But yes, you cannot make them very easily here in Pakistan. 14 layers I have seen, even 16 layers I have seen, somewhat at Kahuta Research Laboratories, KRL Laboratories, or Dr. Abdul Wazir Khan Laboratories. So, message. So layers PCB. Now the problem with having many layers in the PCB is this, that the inner layers, the thickness of the copper inside them actually starts to decrease down, and then you cannot have a large current flowing through them. Then there is a heating problem. You cannot actually dissipate the heat from those layers, and then every time you have to put an asbestos sheet in between this and then an epoxy sheet, and you have to compress down these PCB layers, and then each one of the layers are going to be connected through vias or anything. So certainly PCBs can be made, and I guess in the very start of this semester I asked you people, actually the circumstances were very different at that time, that at the end of this we will have a project as well, and that project, certainly we will be having a project this time as well. You will be designing it, and this time you will be designing a PCB here again. But maybe if the class can actually work on this one, we can ask a 2-layer or a 3-layer or 4-layer PCB from jlcpcb.com or anyone in China, because they can actually make it in very small cost, not as compared to as far as Pakistan is concerned. From the industrial point of view, you won't find more than like 2 layers or 3 layers PCB. Only for defense purposes, yes, KRL has it. and somewhat at CCOM or NESCOM we have also some layers PCB, but not as far as educational purposes are concerned or for industrial purposes are concerned. They are not much layers. The process is very simple. Just the methodology or the uh, industrial grading is actually very important. So it is actually a difficult process as far as you have to make it in bulk. So I will advise you. In fact, I will just share the um link as well for the YouTube video. You can actually go on YouTube and just Google out GLC PCB and find out how many layers PCB they can actually make. Yes, certainly, when you go on to 10 or 14 layers, certainly that actually becomes something like a motherboard. If you are seeing your motherboards of your laptops or computers, they are very, very thick overall, since they are actually of good quality as well, because they have to endure for like 5-10 years or whatever the life of your computer. So certainly they are made and they are costly as well, but certainly when you are making something in bulk, then you can control the cost or something like that. Anyway, beta 138, any issues of regarding files upload or something, please address Sir Bilal with it, because I am not directly involved with that uploading and all that stuff. Whenever I need those assignments to be checked and all that, I actually download it from there. The rest issues, if anyone has it, please consult Sir Bilal. He is also here in the class. So yes, you can. Yes, Yazan Hussain, you can see your PCB designs in 3D. Maybe yes, we can show you. We'll show you today as well. Maybe, or I can have a separate video for that one as well. You can convert this one into 3D, because all the components have their footprints and their 3D pictures over there. So certainly, yes, you can do it. Okay, now I will select some assignments over here, and then I will move on. Okay, let's just get to something. Roll number 53. Rimsha Parvez over here. The problems I have identified in your PCB design is the tracks are very close, no fill areas, no tags. Actually, no tags is actually, though there was some question asked 2-3 days back. What is meant by tags? Tags means that you have not written your name, your roll number, and your group name, and they should be at least of that much size so that they can be printed and they can be actually readable. So tags actually mean that. I will open your file, roll number 53. I will just go on towards my. Let me just have them over here. Experiment number 3, assignments, and these are done. Roll number 53, if I'm not wrong. Yes, 50. Okay, this is the roll number 53. Where it has this 53 gone? I can't find it. Must be there. Yes, okay, this is there. Roll number 53, Rimsha Parvez. Okay. I hope, Rimsha, you are online at present and you can actually see this very easily. One problem, what you have done over here, as soon as I open the file, you have placed these arcs over here. These arcs are of no use, and what the problem is happening, whenever I open the file, these should not be here. So what I will do, you can see I am selecting them, and I will be just deleting them. So whenever I am going to do this something, the circuit is now in front of me. Okay, now the problem, as I hope everyone can see this one, the tracks I have called it that they're very, very close. If you see these tracks where I'm zooming in, they can be made. They can be made very easily if you are making it from a very high grade precision or something, but a little bit distance should be more, because when you are doing it as amateur and you are doing it for the very first time, maybe in the lab, and you are doing it by toner transfer method, you will have problems. So one thing very important, please, when you are making this edges like this, so certainly yes, we have made it right that it should be or not orthogonal, it should be something. So they should be at least something in same hierarchy, or the symmetry should be there. Secondly, if you see this one, this where my mouse is actually at present, this one and this one, they are not in straight line. This is one of the big problems. So kindly, if you are making a bend, take that bend at least something and try to make it something like this. Okay, in this way, now what you can do, you can actually have this track, oh sorry, what this one, so you can now have this one something like this, and now it still seems easy, and this one, now this seems easy, and this one. So avoid very fast changes in the track's orientation. Okay, this is very important. Okay, there is some, I guess, sir, voice is not clear. Why? So beta voice is not clear, I guess. Uh, Beta, please, I will just check my speed test. Don't worry about the screen stuck. I am actually moving with just one. Bilal, please confirm this one. I guess there are some students who are asking that. If your voice is not clear, then certainly this means there is something on your. I'm just checking. I'm just checking my speed on my side at present. Uh, Bilal, can you unmute yourself and answer me, please? Bilal. I'm just checking my bandwidth at present. Uh, just wait, I'm actually checking with her. Just wait, I'm checking my bandwidth at present. Maybe there is some issues on my side, maybe. uh, don't worry on this one. Everything what I have done up till now, it is recorded at my screen grab over here, and 13 minutes and 56 seconds it's already recorded. So I hope everyone can hear me out. I will just share my screen again over here. So don't worry on this part. So those who are asking for the options of the recording, that will be available hopefully, and but the size actually is a very important issue over here. The size of the file should not be that much large, so that's why it has to be in two parts or something, then otherwise it's difficult. Anyway, coming back to the file of this roll number 53 and Rimsha Parvez, I hope everyone can hear me. Bilal, please, you remain with me over here. If there is any issue from the voice or from any of the lagging issue, you can communicate to me on my WhatsApp so that I can be not detract from this one. Uh, Okay, so what I'm doing over here, as you can see, I'm just trying to make this space a bit over here, and the tracks I'm trying to make them so that whenever I'm going to make this PCB, since space is available over here, so you can have this one made like this, and similarly you can make this one, so you can avoid this spacing that is very close over here. So that can be done over here like this, and you can take this PCB, this track over here, which I am now selecting over here. So the point over here which I mentioned over here for roll number 53, the tracks are very close, and the second thing, very important, that there are no fill areas. Now, what I mean by fill area, please understand this thing, because this has to be used in the RGB dot matrix, the SMD, or anywhere else. Now, if you see this whole PCB, there are some tracks like this area where my mouse is hovering at present, or if I can just zoom in, these are very close tracks. Now, the current which is flowing inside these tracks, that can be very small. Maybe each current is not more than like milliamperes or something, but the this VCC point, from here the current is actually going to flow towards this, maybe this is the collector. So from this collector, and then from the emitter, it has to go towards the other resistor, and then it has to go towards the uh, pin of the dot matrix over there. So this current over here, or this track over here, it will be having almost 8 times the current of one transistor. So this has to be of larger magnitude. Now somehow Nimsha Parvez has tried to actually put a fill area, but still it's not that much, and it's not covering all of the tracks over there. So what I will do over here, I will just make this now, making this a little thick. What happens, if you can see, so making this one like this, now it's a little thick. Now making this one thick does not serve the purpose, because when it is going to flow through this small thin line, it still has to pass through low resistance. Remember, thin line means that it is larger resistance. So what will happen, there will be a more voltage drop. Now the voltage drop may be just like 100 millivolts, or maybe like even 5 millivolts over there, but on the scale of this PCB, when you are going to run this PCB maybe at 5 volts or something, maybe the illumination is not going to be that much, because you are not providing uh, the full 5 volts over there. So one thing very important, please, whenever the margins are to be marked, please make them orthogonal, and you can make this margins either with the same bottom layer, or either you can make it with the keep out layer. Now I guess this was not communicated to you, but some people have already made it as keep out layer. It's totally up to you. If you can make it keep out layer or bottom layer, it's totally up to you. So I'm just changing these ones to the keep out layer. Now since I have to make this one connected over here, now you can see what has happened over here again by Rimsha, that these VCC and ground, they are so close. By chance, whenever you are making this PCB, there is a small bridge in between them, maybe sometimes residue is available over there, this will be a short circuit. So what you will do over here, instead of making this an angled and closer to the ground pad, just make it like this, connect it and move it far. You have space over there, you have an ample space over here, so you can use the space. And then now I need a fill area over here as well. So what I will do, I will just keep this a little far, and I will make this one, let me just zoom in over there. One thing, I don't know how many of you know it, pressing the control and using your scroll of your mouse, you can actually make it zoom in or zoom out as well. So here I am making a fill area. Now this fill area has now gone to this one, so I will just drag it over there. It has a contention over here, and now I can actually extend this one and connect this one. So what has happened, the beta, the voice is not clear. I don't know, this is at your end. Lal, please confirm on this one. Actually I'm always seeing this all so I hope it's clear, beta. It's clear. By at least please check your internet over there. Okay, so you can see the fill area. Now this fill area is here, and now I can again place a fill area, maybe from this point to this point, and I can extend this fill area from here to here. And just to make this contact a little more better, I can make this one over here. So now what has happened, the regulator output pin, if this is the output pin over here, 5 volts is connected and this is going towards the upper loop over there. Now I don't know why this seems a little wrong over here by Rimsha, because I have not checked the connections actually. I've just seen the nomenclature over here. If this is the regulator pin, so this should be the output pin. So if this is VCC and you have made this as the input pin, this is the ground pin, so this is the output pin over here. So this 5 volt should be actually coming on from here. Rimsha, please verify this one, because if this is wrong, you are doing some mistake over here, because you have taken the VCC input to the regulator output voltage you are not using anywhere. This is wrong. This is wrong. This is certainly wrong over here, because you are not using the regulator. The regulator nomenclature, if I go on my data sheet over here, for those who have not seen the data sheet of 7805 regulator, the 7805 regulator is input is the first pin if you are holding it in front of you, and then there is the ground pin, and then it is the output pin. So certainly this is going to be wrong over here. You have to take the input pin in this one, and the output pin, this 5 volt, has to be connected over here. So you have connected the wrong nuts over here. Rimsha, please correct this one. All those people who have done it wrong, please correct it in their files, because I have not checked each and every connection, because it's very difficult for checking all those 120 or 125 people connections over there. And so this was the VCC. Now the ground connection, since this is very important, the ground connection has to come from this ULN 2803 IC. Okay, and this you have also written this wrong, beta. This is ULN 2803 over here. Now this ground pin, this one, and from this point, this ground pin, to the connection to this ground and the connection to this ground, this has to be a thick line. Now sometimes the place is not there, you cannot move the pin from here to here. So what you can do, you can just place a big jumper from here to here, and then you can use this vacant space over here in the middle region. Okay, so VCC and the ground, at least in this yellow dot matrix, the connections to the topmost point from where the currents are going to be distributed towards your transistors, they are going to be something in 8 into the transistor current, so it's going to be large. Technically speaking, if it's just more than one dot matrix, then it will be even more problematic. Then you will have to make all the lines thick. Secondly, since when you are going to make this PCB on a fiberglass, so sometimes the fiberglass does not having a large copper thickness over there. It's actually measured in microns. So when you are measuring it in microns, so maybe if you keep Chinese stuff or something coming in and the fiber sheet is very good, or if you place that fiber sheet or maybe a bakelite sheet in ferric chloride for a longer time, you have lost a lot of copper there. So the thickness of the copper is lost over there. So just to be on the safe side, because you don't want the current to actually heat up the fiberglass or the bakelite sheet. Bakelite sheet can actually heat up very fastly. So this is very, very important over here that you make them thick lines. Since you are just beginners in this one over here. Okay, 1, 2 or 3 more problems which I can identify over there. If I zoom in this area, what I can see over here, this is a very big cluster of. Now clusters over here, no issues. If you are making this PCB maybe from some China or something, no issues. But when you are going to make it in here by your own method, maybe toner transfer method, you can see the videos on YouTube channel over there. You can make this wires a little far, no issues in that one, I guess. So you can make this far. Similarly, you can make this wire a little away from here, and so you need some practice over here on this one. So when you have done this, like even you can make this wire here, and then you can have spacing between them, because this pad and this NC7, they are so close, that maybe when you are printing this on the fiberglass or maybe on the bakelite to toner transfer, maybe there is a small connection, and if you run this circuit, it will be a short circuit, something like that. So please avoid. And secondly, very, very importantly, I have seen in major PCBs up till now, you can move this dip switch a little here, and make these tracks straight. That can be done, I guess, with not much compromise over there. These NC7 and NC4 you can just make, or maybe make the male header a little move away towards the left. This will be more easy for you. Okay, because straight lines, they do not have that much inductance of. So now this is a little difficult term over here at present, because these are not high speed electronics, but when you will move on towards this PCB design for some high speed electronics, then the wavy structure of the tracks can also have some stray inductances or stray capacitances. Because what you are doing over here, if I just zoom in over here, you are having this pad and this track very close to each other. So maybe there is a stray capacitance in between them, but capacitance of maybe micro, well, not micro, maybe in fact picofarad or nanofarads, but still it is going to be there, and that can be detrimental for your circuit if it's a high speed electronic circuitry over here. Plus, one thing very important, I have seen some PCBs, they have been very good. They have used the space very good over there. Please avoid this orthogonal, non-orthogonal structures over there. It should be totally 90 degrees from all border margins, and this dimension chart should be at the out. And I have seen some assignments as well, those who have not taken the dimension fully over here, because you can see I have to drag this one. So just to make it 120, they have just put 120, and it's not the actual dimension over there as well. So one thing, and again, just again one mistake over here from this PCB, then I will move on forward. I told you, don't make it slanting like this, make it something like this. This makes it easy for the tracks to be actually separated from each other. You can see now I have made it like this, and I have made it something like this. This is completely okay. But in fact, you can make it far over here as well. You can make it something like this. You can make this one over here. So making them far over there actually makes it easy for you when you are going to actually, so probability of a problem is going to be reduced. This pad and this track very close. You can take this too far, and then you can actually, I'm just saving it over here because I have done just some work over here on this PCB. So Rimisha, please rectify this mistake. All those people who are in this assignment list over there, you have been awarded some marks over here, maybe like 5, 6, 7, 8 or 9 or 10. 10 is actually something very good work done, certainly over here by roll number 12 Hamza Akhtar over here. Those who are at 6, 7, 8, getting you the marks does not mean that you are going to throw this file. So if the university opens and the labs are going to open, you have to make this PCB. Okay, so please rectify all the problems or remarks I have given on your assignment over here. Please rectify those mistakes. Maybe if we have time, me or Sir Bilal will again check these assignments again, and we will see if you have rectified all those mistakes. So the marks which you have gained, we are just making you adapt to this one, so that the next PCB you design, which is viewer, I guess this is submitted over here, that is the RGB dot matrix, so you can actually work on that one. Now there has been some questions about the RGB dot matrix as well. I guess there is some message. Okay, Vikas Ali, please, and when I will check it, then you can actually have it over there. Let me just check one of the PCBs over here as well. Okay, in fact, let me just show one very good one. It's roll number 62. Abdullah, I guess this is Abdullah Subur, I guess. He has done a very good job. I guess I don't know why you have written the name Abdullah Senpai. I don't know why this is fun. Anyway, 62 roll number. So Abdullah Senpai. Okay, or Sabur, I don't know if this is Abdullah Sabur or Abdullah. Yes, this is Abdullah Sabur. Okay, now this one is excellently managed. This one excellently managed. You can see the size 114 cross almost 106 over there. Very well small, and so just wait. Actually, this is over here. Okay, so you can see over here he has done some mistakes, but one very good thing, you can see these are straight lines. These are very straight lines, some very good straight lines. Yes, he can do this one, the same thing which I have been telling. You can make this one like this, and you can make this, because when you are moving this track very close, you are actually very close to the pad. So when you are entering a pad, the track should be straight. It should not be bended, so that it does not have any stray inductance or capacitance with the other pad over there or something like that. The spacing over here is also uniform. You can make it even more if you have some space. You'll see had space, but anyway, these are very good. This is a very good PCB overall. I like this PCB. overall, and the red color tracks are not that it's actually a two layer, it's actually just wires over here. Now no harm in actually having wires, no harm in actually having wires, but when you are making wires, if your size is reduced, no harm in that. Okay, so as such, if the size is reduced and you have a lot amount of wires over there, then it's, and the fill areas are also efficiently used. You can see over here, if this is the VCC and the ground, the track is very big, and he has moved that fill area track on all three sides. So the 5 volt line or the ground line, it's available on all three sides over there. So this is very excellently managed. There is the capacitor also available over there. Yes, one thing he has actually done a little wrong from the electronics point of view. You have placed the capacitor here. It is not close to the regulator over here. From the regulator point of view, it's wrong. But from the point of view of your this dip switch over here, if you have placed over there, it's okay. But overall, this is a very good PCB by Abdullah. So that's why I have given him 10 full marks over here. Let me just cover. Okay, this is by Akhtas Ali, 42 roll number. Let me just discuss this one. 42. I have given you, I guess, the green color track. Yes, the reason of giving you the green color track, your PCB is also very good designed, but what you have done over here, you have done these red color tracks. Now you cannot put a jumper wire from this hole, which already has a resistor, and you cannot place it over here. If you want to make it, the easy way around is this. Let me just do one work over here so I can actually show you. Take this track over here, bring this one down as well, and bring these two lines here down as well. So what you are doing over here, make this blue color and then now make it red color. Okay, and here at these 4 points, make these 3 lines also on the left, and from here again just make a wire and then make jumpers. Otherwise the whole PCB is very good, and I like the PCB again because you have used very good fill areas in the top and then good fill areas over here as well. This seems very good, but again one problem again over here, that when you are connecting this fill area with the other regions over here, you have not connected the ground connection very solidly with the other ground area, because if this is ground, so I don't know, this is 5 volts over there and this is ground over there. Where is the 5 volt region? Okay, you have made it over here. Okay, that's good. Okay, anyway, so some mistakes over here which I just pointed out in the first PCB as well. That is very Rimsha. You can see over here, and avoid this whenever you are making these turns. Please avoid these ones, so that these edges should not be there, because whenever you are going to move them, you are going to have some problems over here like this. So please avoid this one. You can see here again, this is a small orientation mistake. Avoid these ones, because when you are going to make this PCB, it will have some problems. So 42, yeah, you have submitted the file, but I took this files over here at approximately you can see the date modified is 10 on 10th of this month I took it. So I don't know about it. Anyway, yes, you may have submitted it, but I marked your marks over here. So I hope everyone who has been evaluated up till now, those who have still not been evaluated, the session of this like 40-50 minutes, I made it so that everyone can know that what types of problem you are having. And please do not submit without contentions removed. Contentions have to be removed. These are very, very important, especially this roll number 71, this roll number 4, Fatma Naseem, and this roll number 9, Fatma Tarek. You have not removed the contentions. I guess you have just placed it and then not done anything over here. So up till now, I have approximately, this is the updated list by today morning. I updated it over there. This is approximately 55 students I have marked, and meanwhile there are still some remaining. You can see they are like approximately 60 almost more remaining over here. Meanwhile, I will take some time on this one and I will complete it maybe by tomorrow or day after tomorrow. But the purpose of this session over here was simply just to make you aware that the problems which have been identified, you can do them, rectify them in your RGB. Okay, now there have been some questions regarding the RGB. If I go back on just answering those over here, there have been some questions very much coming on. This is the circuit diagram, as you can see over there. Everyone has it over there. I've placed it on the web as well. Not on the web actually, I gave it to the CRs. Okay, now here the fill areas, I hope all have submitted it, but anyway, still, if you want to find out where actually the main current is going to flow over here, this wire, which is VCC, which is connecting with this 4.7 kilo ohms and 10 ohm resistance, this has to be very large. This has to be very thick. This wire from this collector of 2SS684 has to be connected with this row pin number 6. This is also has to be a little thick, not that much thick, just like this 5-volt line, but it has to be thick. Rest of these three wires, 1, 2, 32, 30 pins, these pins, they can be small. Okay, that's not a big issue because we just have one dot matrix over there, so that's not a big issue over there. But one thing very important, the ground pins over here, the access ground pin is not shown over here in this ULN2 over here, this one. So this ground pin, and this ground pin, when it is going to be connected with this ground pin, please make these thick lines, so that, and this ground has to be connected with this ground of this IC, because current has to flow from here to here, and then it has to flow towards this transistor, and then it has to flow towards this dot matrix, and then through these resistances to these ULN 2803 Darlington resistors over here. So please, wherever the currents are large, please make them in thick lines so that it can be. Now there has been a lot of question coming up that how we can make this a two layer. Now please, whenever you are making a two layer PCB, since this is a little presentable type of a PCB in which you have a dot matrix, and maybe for anyone who has submitted the best RGB dot matrix here, I will make that PCB here in my lab, and I will show you over there, and I will run that one as well, so that everyone can have a look over there. But maybe we can do it for the SMD, not for the through hole one, or maybe we can do it for the through hole also. But one thing very important, when it has to be a presentable form of a circuit, since what is presentable in this circuit, the RGB dot matrix. So that's why I asked you from the very first day, or maybe Sir Bilal has also asked you, that the RGB dot matrix has to be placed on the top layer, which means that when you double click any item, let me just let me open some RGB over here, maybe from the last year sessions. I have that RGB as well over here. Where is that RGB? Let me just find out. This is SMD. I don't want the SMD one. I need experiment number 4 RGB. Actually, can't find one. One. And anyway, actually I can't find a PCB which is double layer. Anyone, Bilal, can you send me some file? Any student has submitted the RGB. Maybe if Abdullah Sabur has actually sent it, I guess he is one good person. I have liked his designs up till now. So please, Bilal, can you send me? Please just maybe WhatsApp me, or maybe just email me, so I can just open it over here. I don't have a file actually, maybe they are in my other computer. Acha, anyway, meanwhile, when this is being done over here, let me just talk about it over here. So you have to place this dot matrix on the top layer, and all other ICs you can also place them on the top layer, but since it has to be presentable, you only want the dot matrix to be visible, and the rest of the devices can be placed on the back side, which is the bottom layer over there. So when this dot matrix is going to be placed on the top layer, it can only be soldered on the back side. This is very important. That's why the RGB dot matrix I have asked for is going to be made soldered on the back side, and you are going to have all the ICs soldered on the back side also, or maybe on the top layer side. It's totally up to you, because these are all through hole component. But as far as the RGB dot matrix is concerned, please make sure that the pads, these pads are from pin number 1 to pin number 16, or from pin number 7 to 32. They are actually made in such a way that they are soldered on the back side, which means that the tracks coming out from these pins should be at the bottom layer. This is very important. Now, sometimes it is also possible to solder it on the top. How? I will share one picture. At present, I don't have that picture with me. Actually, I promised to Sir Bilal as well, but I don't have that picture with me. I will share that picture as well, but for that purpose, you will have to place a female header. I hope everyone knows what is female header. And then that female header is going to take that RGB dot matrix. That female header has to be soldered from the bottom side also and from the top side also. Now that's a little difficult task, you being as an amateur or just as beginners over here. So that's why I'm asking you for the RGB dot matrix to be soldered at the back, placed on the top layer. Okay, the rest of the circuitry, it's totally open to you. You can place it on the top as well, but as far as the beautification wise is concerned or aesthetic is concerned, it's better that you have only just have one PCB, and on that PCB on the front side you only have visible the dot matrix over there. The rest of the circuitry, these three dip switches, or these three ICs over there, or these 16 transistors are there at the back side. It will actually make a big cluster, but if you want to present it in some box or something, then you only want to show the dot matrix. You don't need to show the resistors or whatever stuff is over there. So this is very important, that when you are having this RGB dot matrix. So I will ask Sir Bilal to maybe give some leniency on this one, though, that those who have submitted it, they can be returned that file, and if you want to edit it, you can take 1 day more on this one, and so you can actually resubmit it, and meanwhile I can check your yellow dot matrix assignment, and then we can move on toward the experiment number this 4, that is actually the assignment over here. So I hope any questions with this RGB dot matrix, please write down in the conversation window. Meanwhile, Sir Bilal has actually sent me any file. Please share with me. Bilal, I hope you can hear me. Okay, I just let me just yes, I have this assignment over here. Okay, yes, you actually, Bilal sir shared with me one file. Actually, I had this file before as well. Let me just show you. I will just show you these files as well. It's taking a lot of time. Anyway, I will just show them over here. Actually, I was asking for the PCB doc file, Bilal. Anyway, I was asking the SMD version. This is the SMD version. SMD fixed manufacturing. Okay, if you see this one, what I have done over here, this is the yellow dot matrix PCB, which is actually now the next task for you as well. You can see what I have done. All the components, the transistors, the resistances, they are on the back side. This is a single layer PCB. This is a single layer PCB, and this is not a double layer. So actually, I wanted a double layer PCB doc file. So this is the yellow dot matrix. You can see the jumpers over here, just a little bit visible. Rest are down below the yellow dot matrix. This is the VCC to ground connector over here, and this is the male header. Now, if you want to see the back end side of this one, this is the same PCB. I will just show you the design as well over here. You can see this is simple single side PCB, and this is the back end of this over here. Not a very good soldering. It was done in quite much haste, but still anyway, you can see the size of this SMD resistances. Now, how the sizes cater on for it, I will just show you. I will just show you the tables as well. But this is the same ULN 2803 IC. I hope everyone can see this thing, and you can see this is the 36 ohm resistance over there. Then you can see this is the 390 ohm resistance, and then this is the 100 ohm resistance, and then you have this. So how this is read actually, I will just tell you also on that one as well. This is 4.7k resistance over there that is actually connected with the resistor. This is that main transistor over there, which I will change over here for the SMD, and then this is the 2N3904 transistor which has been changed. You can see the size of this PCB, the yellow dot matrix. This is the same PCB, and the size of this PCB is very small. It can fit in my palm. Okay. Now the same PCB, if it is done for the yellow dot matrix, if I go back and I show you the yellow dot matrix on a Vero board, this is the shape. Okay. Now here the vacant space is quite a lot, but over here you can see it's taking a lot amount of space. This is a large Vero board over here being used, so this is very much space taking. So now reduction can only be done in three aspects over there. One is the resistors, one is the transistors, the other one is the ULN 2803 IC. There are some questions actually on the conversation window. Let me answer them. Please, roll number 115, please consult with Sir Bilal on this issue. He will actually answer better on this one. What do I mean by RGB should have only top? RGB means that it has to be placed on the top layer. Physically, it is placed on the top layer. So this means their legs are going on the bottom side. So it has to be soldered on the back side. But somehow, in some case, if you are a good professional, you can solder it on the top as well and the bottom as well. But you will require female headers to be soldered at the top as well and the bottom as well. I will share one small video, maybe after this lecture I will upload it over there so you can have an idea. But please have this restriction this time, at least for this PCB, for the RGB dot matrix, because the size is already going to be very large because of 3 dip switches, 3 ULN 2803 ICs, and then transistors. So please make the top layer the RGB dot matrix which are soldered at the back side. So the pins, which are these pins over here, so this is the yellow dot matrix SMD PCB. So over here, if you can see over there, these should be bottom line tracks. These 1 2 3 4 5 6 7 8, these should be bottom layer tracks over there, should not be top layer. So these pins should be. Now there is one way of actually making auto routing behave them as bottom layer. Since we know this is a multi-layer, so this can go to top layer and bottom layer when you will click this auto routing button very easily. So what you are going to do, you are going to double click this pad, and over here change the layer from multi-layer to something bottom layer. What will happen now, whenever you will click the auto routing, it will always take it as a bottom layer. Okay, so this is very important that you can make it as the bottom layer, and then it will always have the blue color track connected with it when you are going to do the auto routing over here. Okay, so this is that one. Okay, now coming on to the SMD PCB, roll number 115, I guess you have uploaded the screenshot. Please don't upload the screenshot. There were, I guess, 3 files asked for you. One was the PDF, one was the PCB doc file, and I guess the third one, I don't remember it. It was asked over there. So please consult Sir Bilal on this issue. Okay, now when you are going to convert this PCB of yours, that is the yellow dot matrix, into its SMD counterpart, you will require 3 components which were inside this one. The first component is the transistors, second one is the resistors, and the third one is the IC. First of all, now opening the IC over there, since this is ULN 2803. Now you have used this packaging. I hope everyone can see this one. You have used this packaging over here. Now this packaging is very large. It's also height wise also large. It also lengthwise also large. And if you want to know the exact dimension, just scroll through the bottom of this data sheet, and you have the sorry, this is the SMD IC. Where is the actually the through hole IC? Yes, through hole. It's not here. I don't know where it is. Anyway, the through hole is not available in this one. Anyway, so this is the SMD IC over here. Now, what is the size of this one? As you can see, this is having the body size. The body size means this the dark black color line over here. And if you see over here, this is approximately 7.5 mm, and the length over here is approximately 11.5 mm or something near about it. So when you are talking about this one, from where you are going to get this over here? Now you are going to get this one. If I go on my PCB doc file, since this is going to be first time dealing with your SMD component, so I will tell you the libraries over here. If you double click this one, since this is an SOIC packaging, I just showed you this is an SOIC packaging. This is small outline package over there, SOIC packaging. So I will go and see on this one. The packaging is, the library is SOIC underscore 127P underscore L. Now what this means actually, that this is SOIC packaging underscore 127 pin. Actually this is the maximum number of pins that can go. Now what type of pins are available, let me just show you. If I go in the place, if you go in the component library, it takes some time. Again, this is a 8 GB RAM, but still it takes time because the libraries are quite huge over here. So okay, now I have it over here. So I want SOIC library, so I will click S over here, and this is the SOC. I don't need SOIC, I need the SOIC, which library is by default inside it, and you must have downloaded it over there. So okay, so this is the SOI. Now one thing very important, you will every time for any library, mostly in this LTM, you are going to find out SOIC underscore 127P underscore L. There will be M, there will be N. What happens in these three ones? L is for beginners, M is for like something very good professionals, and N if you want to miniaturize even more. So the pad size are a little reduced. Okay, I can't give you the exact mathematical dimension what is the, but you will find the same footprint in L also, M also, N also. So you can see there is SON packaging, there is 40P, and then there is LMN. So I will always be sticking, and I will advise you being a student to be sticking on to L. So when you click this L SOIC underscore, now you can see there are many ICs available over here. Now we know the body size from our data sheet, that is SOIC. I know that SOIC packaging which I am using over here, this is an 18 pin over here, and this 18 pin has a size of approximately 7.5 into 11 point. You can take the average of 35 and 75. So this means that if I go back on over here, I will be requiring 18 leads. So where is the 18 leads? There are two going. So what you can see over here, there is 11.6, 7.5, the both are almost the same. This one is AL, and so you can see there's a little shrinking of size over there. So it's totally up to you what you want to take, this 18AL or 18A. Just the pads are a little bit over there lengthwise, otherwise it's the very same. So you will select one of these ones over here, click OK, and this gives you the IC. Now when this IC is selected or this footprint is selected, this gives you in one color, that is the top layer, because normally SMD components can be. If you want to change them to the other layer, okay, double click this one and layer, this is top overlay, where it is going to be placed. Actually this is hiding a little over here in my screen at present. Let me actually can't move it over here. This has to be changed from here actually. Okay, actually the option is not visible towards you, I don't know, because of the recording. So when you will change it to bottom layer, okay, what will happen? It will change to this one. Now you can see when I've changed it to bottom layer, the IC has mirrored itself. This is very important because you are seeing from the front side the IC. So this is just like a glass, and you have placed the IC from the back side, and you are reading it or you are seeing it. So pin number 1 is still this one, the dot point. Pin number 2 is here, pin number 3, pin number 4, 5, 6, 7, and so on, and like this. But when I will change it back to supposedly the top layer, you can see it comes back over here. So this is the mirror image. This is very important, that the IC when it goes back, so you are seeing from the front, it's just like a glass sheet or a plastic sheet, and you have the IC placed on the other side. Okay, now your yellow dot matrix which you have to make, it has to be single layer. The first single layer has to be single layer, just like this one which I have shown over there. You can use this as your starting point as well. So the IC is there. The next thing which is required for your PCB is actually, apart from this IC, is the two transistors first. Now the two transistors is the first one, 2N3904. Now when you have a 2N3904, when you go in the SMD category, you have used already this 2N3904. That was in TO92 packaging. This time you have to use either of these two. Now normally, since I am accustomed with the Hall Road people and all that stuff, I know that SOT23 packaging is available, okay, in SMD, and it's very small size. So this is SOT packaging, that is small outline package over there. So SOT23, and the number printed on it is 1A. If you can go in this table, you can see this is number is MMBT3904. The marking is 1A, and the packaging is SOT233L. So if I now go back on my software, I will not go towards the library. I will just go towards the components again, and this time I require SOT. So I will just scroll down here again, and SOT23. Now again over here, SOT23, there is L, there is M, there is N. So if I will go to L, now here you can see the first thing first, I have this SOT23 3L, and you can see the body size over here. If you want to confirm the body size from there, 2.9 into 1.3, I will just go back on my transistor again, and I will just scroll down to the end of my data sheet over here. As you can see this is approximately the same, that is 1.3 plus 2.9 over there. So you can see this is the same size of that transistor which you can see over here. So the same transistor I am selecting over here. This is the first transistor over here in this library, so I have just selected it. Again, the same thing when you are seeing it from the top. Okay, this is very important when you are seeing it from a data sheet point of view. If I go back on my first page on this data sheet over here, you can see this is base, this is emitter, this is collector. When you are seeing it from the front side, you are holding the transistor in the front side. So this is base, this is emitter. So this means when I will go on this one, if I just zoom it in this designated file, this is my base, this is my emitter, this is my collector. But now what will happen? See, this a dot is connected with base. Now when I will double click this one and make this as the bottom layer, what will happen? You can see the dot has moved here. So this is vice versa. So it has gone in the mirror, because when you are seeing the PCB, you are actually seeing the PCB as a glass plate. So the pad has been placed over there. Be very careful and putting these transistors and their connections, because here if you do a mistake, then the whole PCB will be lost. This is very important. So this is again the base, this is a meter, this is collector over there. So this is the first transistor. Now the second transistor that you require, now you have been using 2SA684. This time you will be using BC689. Now this transistor I have selected over there because 2SA684 is not available in SMD. So I have selected this BC869, and this is available at Hall Road, very easily available. Now the packaging of this is available in, if I just scroll down over here, this is available in BC689. The packaging is, if it is given by Philips over here, that is SOT89 packaging over here. I'm not concerned with this EIJ packaging, I'm concerned with this SOT89 over there. So this is actually another software library that is not available over here in LTM. So when I'm talking about SOT89, now we are not concerned with this 16 and 25 number, rest till the library is the very same. So when I will move on towards, again I will go on towards this component, and again I want SOT89. So already 89 is there, SOT89L, and you can see the IC. Now here if you see the data sheet again, the data sheet is giving you SOT89, and the shape of this transistor, as you can see over here, it has 1, 2, 3, and then there is a pad at the top. There is a pad at the top which is connected with pin number 2. What is pin number 2? That is the collector. And since this is a PNP transistor, the collector is going to be connected with the load over there. Okay, that is actually the pin of your dot matrix from where the current is actually going to flow inside the yellow dot matrix. So pin number 1, 2, 3, 4. If I go back on my software again, so I need something. This is not the exact shape, the first one. This is also not the exact shape. This one something's weird. So this one over here, because this is the dot over here, and in the data sheet also I had this dot over here. It can be opposite way around as well, I guess, if I'm not wrong, if I find out on the data sheet over there. Okay, the dot has not been placed over there. So anyway, the dot can be missed over there. You can use any of the two bindings. So SOT 89L is being used over there. So this is that SOT 89L. Again, same. You can use the same data sheet nomenclature. Please be very careful when you are using this over here, because again, when you will have this one, this one you are seeing it. This is the pin number, which is that a video is being shared. I guess there is some problem on your end. I have shared the meeting. It is still being recorded, so don't worry on that side. 3, 2, 1. What is 3? 3 is base, collector, emitter. So if I go back over here, this is my sorry, just look at. This one is base, collector, emitter, BCE, which is the normal. So this is B, this is C, this is E. And if I just show you where I have used these transistors over here, where are those transistors? You can see this is one transistor. So this is, since this is opposite mirror side, this is very important. So this is B, this is C, this is E. So you can see with the C, this is connected with column number 1, the column number 1 of the dot matrix, and then this is E. So over here, this is connected with the will be certainly connected with some resistor. So you can see this is connected with some resistor, and then this is connected with the 5-volt line. Okay, in this PCB you don't have the regulator. You have to add that regulator yourself. It's not included inside this one. You have to add it yourself. So what you are seeing at present is just a yellow dot matrix PCB, and it's just the 5-volt line over there. Now one thing, since this is going to be an SMD, and here the actual purpose of using SMDs is this, that you have to miniaturize it. You can just have the power regulator as well, but no need of the bit switch over there. The same bit switch which you have been using up till now. If I go back on your experiment number 3, this bit switch, no need of this bit switch over there. This one dip switch over there, or we call it as a bit switch because bits can be handled. No need of this one, no need of this one. Just attach a male header here, just attach a male header over here, so that we can just turn it with the microcontroller, and then we can run it very easy. So this is very important that you have it in this way. Okay. Okay, now coming on to the last thing, this is very important, resistors. Now if you have resistors which you have used up till now, they were carbon film resistors, very cheap. You can get like 3 per dozen, rupees 3 per dozen, very easily, and they are quarter-watt resistances. But when you are moving towards the SMT stuff over there, the SMT resistances comes in various sizes. I hope everyone can see this screen over here at present. There are like many sizes available. If you see over here, the first topmost is 2512. Now whenever you are going to go haul road and you are going to go shopping for SMT resistances, each resistance should not be more than, like, if you are talking about something in the range of 1212, because you will be not using this 1812, 2012 or 2512, because they are very big resistances. I'm not going to ask you to use them. You will be using 1210 and 1206 over here. So this 1210 and 126, not more than, if you buy something in bulk, and I will advise, if you are going to work on this one and you are going to buy this, I will advise to buy in bulk. Maybe the CR can, but be very careful in handling this. Why? Because 1210 size means that it is just 3.20 into 2.60 mm. This is very small. This is 1210 3.20, because the name is given as 1210 because this is 0.12 inches by 0.10 inches over there. And if I show you the actual PCB, which I have also shown you just now, this is that PCB over here, and this 1210 PCB resistor is this one where my mouse is hovering. This is 1210 PCB over here. So this is that same 360 ohms resistance over there. Oh sorry, 36 ohms, not the same one over here. What value we require, we will discuss it later on, because we are still not making this PCB in practical. This is just the software design part over here. So this is the 1210 size. This is also the 1210 size, and 1206 size. You can see this is that one, 390. Now, as you can see, the size is large. This means actually that you are going to have more power rating inside this one. So when you have more power rating, so what happens, the power ratings are based on this one. If you see 1210, it is quarter watt. Now what is that quarter watt? Is the same resistor which you have used in your Varroboard circuits or up till now any PCB. By what I mean, that you have used this one, let me show you some pictures as well. This is a quarter watt resistor, this one, the same which you have used or taken from the lab, and you have made it your Varroboard PCBs, or you have designed your PCBs up till now or Varroboards up till now. This was a quarter watt resistor. So you can see the size is so much reduced over here in this case, and you can have it in such small sizes over there. Now if I go back on the chart over here, which is the SMD power resistor rating, if you want to have a half watt resistor, then you will have to go towards 2512. But since this is just one simple yellow dot matrix, then certainly you will require only just 1210 quarter watt resistances, because yellow was working fine even with quarter watt resistances. And then for 1206, this is 0.125, that is very even half of this one. And then if you go on towards 0805, 0603, 0402, 0201. Now 0201 and 0402, even you won't find them in Pakistan. 0603 are there. And let me just give you a little idea about let me just show you what I'm actually asking you. Let me just show you. I hope everyone can see this, and I will share this one. Actually had this one over here, SMD resistor 0603. So this is very important. Okay, and if I go in the images over here, okay, now you can see the size difference. This is very important size difference. You can see the size difference. Up till now, if I just copy this image maybe, and I can place it in your sorry, this one, the Teams window. Let me just copy this image over there so everyone can have a look at this one. And nope, this is pasted. It's still uploading. Anyway, it's still uploading. So if you see this one, this image over here, let me just upload it over here. Okay, you can see the size difference. This is 1206, this is 0805, this is 0603. What is the width of 0603? This is 0.85 mm. And the tracks you have been using up till now, they were 0.8 or 0.7 mm. So you can see the thickness of the resistor. The size is so small that you don't even need to actually have more space than the track. Now the tracks can also be reduced if the current is small. Now since you are actually working on something power resistors over here, you can call 1206 and 1210 as the power resistors over there. So certainly this means that you have something, you can use 0603 in your any electronic circuitry where the current is not that much, where you're just having a control from your microcontroller or any other circuitry over there. So this is a very simple one, and I hope, sorry about this, this is the Teams over here, and I hope everyone can see this one. I have uploaded this image over there in the conversation window, so I hope everyone can see this image over there. Okay, so these resistances, you can find them very easily inside chip resistor underscore M underscore L underscore N. It's totally up to you. Now let me show you where you are going to find them. This is the again place, and you are going to go in components. You are going to go in the chip resistor. So these are chips resistor, so that's why okay, this is chip resistor. The chip capacitor is also available, but over here you can have the chip capacitor also used over there. It's totally up to you. I will update on this one that which capacitor you have to use on this one. I will not going to tell anything about here. So when you are talking about chip resistors, you have to use which size. It's totally up to you. You know the chart you have in front of you, so the chart requires over there whatever size you want to use. You can use any resistance over there. Okay, so in this way you have to make this PCB, the same PCB which is in front of you. Male headers you already know, but everything has to be in bottom layer. Everything has to be in bottom layer. You can use a lot of wires, but smaller the vias, or so smaller the vias, number of vias, Smaller the size of the PCB, better. I'm not giving any size over there, but I guess it should be less than 90 cross 90, at least 90 cross 90, with the regulator, with the capacitor, and with the yellow dot matrix on the top layer, soldered on the bottom side. You can see if I double click this one, this is in the, sorry, this is in top layer. Okay, this is in top layer but soldered on the bottom side. So you can see this is in yellow color over here. If I change it to bottom layer, this will actually go in a dark yellow color. So this means it's going on the back side but soldered on the front side. But we don't want it, because we are just designing a single layer PCB, a yellow dot matrix SMD PCB single layer over here. This is your next assignment for the next week. And for the RGB dot matrix, since I have given some clues over here today as well, just to rectify it, and since I want you to learn this art of actually designing this PCB, so we're giving some 1 day more over here. So maybe Sir Bilal will update the links again, so all of those who have submitted, they can submit it again with some rectification changes, and meanwhile I can check the yellow SMD resistor over there. Track size on this one, I have no issues if you can use something 0.65 or 0.7. 0.65 are enough, because this is just one SCS dot matrix over there. But yes, again, fill areas, again, please see this fill area. This fill area has to be inside. It has to be thick one, so that it can have, you can see this is the ground track where my mouse is at present, and this is the same jumper wire, because I can't avoid it. So what you have done over here, it's a big thick wire over here, and as you can see in the pictures as well, as I showed you, that this picture, you can see it's not visible actually over here, but if I show it from the back side, you can see this picture, this thick one, this one. So you can see this is a thick connection over here to here, and then this is going towards over here. So you can see the thickness of the fill area, it's quite large, so it can still work over there very easily. So it's working fine over there. So I hope this is clear, and everyone can actually make this very easily. It's since it's just a repetition, I will advise you, please take the same yellow dot matrix PCB which we have designed, take out the resistors from it, and certainly the resistors and all that. Netlist is already there, you just have to place the resistances and all that stuff. You can auto route it also, but when even you auto route it, contentions will be there, because it's a single layer PCB. You will have problems over there, but again, you can formulate these problems by removing the contention. And please again avoid very close lines. Still you can see I have made this very close, but I was able to make it practically. As you can see over here, these lines are very much clear. You can see these are very much, and this is by toner transfer method. This is not something fancy method over here, it's just simple toner transfer. You can see the cleanliness of the PCB. So you can do this as well at your home as well, and maybe in some like 1 or 2 weeks we are going to talk about the same PCB method over there. In fact, I have these pictures here as well. As you can see, this is the same PCB. I took it from the pub sheet. I cut it with this blade over here, and then after cutting it through the blade, then I had made it a little clean using a sponge, Scotch-Brite actually, and some liquid soap. And then this is the same print on the toner transfer method, and then you can see I am actually transferring this circuit over here. This is coming on through the rollers, which are also available in the department. I have also them in my home lab, and you can see now the print is transferred. It's a very beautiful print. Some tracks, some area is a little hazy, but anyway, it does not have any problem over there. Then I have used some markers so that it is a little over here. Then this is in ferric chloride circuit, as you can see, and I'm just moving it over there. And then afterwards you can see this is the, now to remove this toner over here, I have used some acetyl or something, alcohol tape paste or something, rubbing liquid. So this is the PCB, and then this is the drilling part. As you can see, this is being drilled over here, and then when the drilling is done, you can see the PCB, it's drilled over here. And then afterwards, this is the soldering. Not a very good of soldering actually, I did it in very haste. So otherwise, for SMD soldering, the wire or the soldering wire that has to be used has to be very small. I used a very thick wire, so that's why there are big blobs of SMD, sorry, the solder near the SMD resistances over there. And this is the front side after placing it. In fact, I have also the video of this yellow dot matrix PCB working, so I will share that one also on the YouTube channel. I guess it's already there from the last year, so I hope so. This is still enough over here. And any other questions, G? So I can just In fact, I will just stop this and start uploading this one on the YouTube channel over here. So